In this lecture, we will be discussing another solved problem from Regular Languages and Finite Automata. And this question is from GATE 2012. Alright, now let us see what is this question. So it says, consider the set of strings on 0, 1 in which every substring of 3 symbols has at most 2 zeros. For example, 001110 and 011001 are in the language, but 100010 is not. All strings of length less than 3 are also in the language, and a partially completed DFA that accepts this language is shown below. So our task is to find the missing args in this DFA. So this DFA is not complete and there are some missing args in this DFA, and our task is to find out which is the missing arg. So we will have 4 options A, B, C and D, which I will be showing you later. But before that, let us first try to understand this question and what is the kind of language that is given over here. So it says the set of strings are from zeros and ones, and then in this language every substring of 3 symbols has at most 2 zeros. That means if you take any string in this language and if you take a substring of any 3 symbols, those 3 symbols should have at most 2 zeros. That means if you take a substring of 3 symbols, it should have not more than 2 zeros. At most it can have only 2 zeros. If it has more than 2 zeros, then that string will not be in the language. For example, let us see this. In this string 001110, if I take any substring of 3 symbols, that means if I take a combination of any 3 consecutive symbols, it will have only 2 zeros in it, not more than 2 zeros, right? So let's say that I am taking these first 3 symbols 001. So if I take the 001, we see that in these 3 symbols only 2 zeros are there. Or let's say that I choose the second, third and fourth symbols. Then even in this it is 011, so we have only 1 zero in it. Now let's say that I am choosing the last 3 symbols 110. So even in this we see that there is only 1 0. So however I make the combinations, I see that if I take a substring of 3 symbols, it will only have at most 2 zeros. So this string is accepted, or this string is a part of the language that is given. So now if you see even this string, you see that if you make a combination of 3 consecutive symbols, you are going to have at most 2 zeros only. Like for example, let's say that I take the last 3 symbols 001. Here also we are going to have only 2 zeros. So these are the kind of strings that are accepted in this language. Now if you look at this string over here, 100010. Here if I take the first 3 symbols, then there are only 2 zeros, it is okay. But if I choose the second, third and fourth symbols, if I make a combination of 3 symbols like this, we see that it is having 0, 0, 0. 3 zeros are there, and this is not acceptable because we are allowed to have only 2 zeros at most in this language. So that is why this string is not in the language. So I hope you understood what is the meaning of the language given here. And it says all strings of length less than 3 are also in the language. That means any string whose length is less than 3 are also there in the language. And this is the partially completed DFA that is given. So it has a starting state E, and it has states 0, 1, 0, 0, 0, 1, 1, 0, 1, 1 and Q. And we see that among all these states except Q are final states. Q is not a final state, and apart from Q, all the rest of the states are final states. Now let us look at this line. It says all strings of length less than 3 are also in the language. So you see that all strings of length less than 3 are also in the language because all of them are final states over here. Now we have to complete this DFA. So in order to complete this DFA, we need to find what are the missing args in this DFA, and we will be having 4 options which I will show you now. Alright, so these are the 4 options A, B, C and D. So these are the transition tables for the missing args, and we have to find out which is the correct transition table which will show all the missing args in this DFA. So we know what is this DFA. It should accept languages in which every substring of 3 symbols should have at most 2 zeros. So it should not have more than 2 zeros. Alright, so one method to solve this is you can look at this DFA and you can try to find all the missing transitions in these states, and you can try to see all the possibilities and try to complete this DFA. But we know that that is going to take a lot of time. But as time also is an important factor in your examination, we will try to see how can we solve this problem in the minimum possible time. So for that, first of all, let us look at this DFA. So here we have the starting state E, and in E, if you get input 0, it goes to state 0, and in state 0, if it gets input 0 again, it goes to state 0, 0, and then in state 0, 0, we don't have transition for input 0 or 1. That means state 0, 0 is not complete. So if we are to complete the state 0, 0, let us see where should it go on getting input 0. So remember that in our DFA, we are not allowed to have 3 consecutive zeros coming together. So we should have only 2 zeros at most. So in this state 0, 0, when you reach the state 0, 0, we already have 2 zeros, 0 and 0. Now, if you get input 0 again in this state 0, 0, that string should not be accepted because it is going to be 3 zeros. We have 1 0 from here, second 0 from here, and if you get one more 0, it is going to be 3 zeros. And if you get 3 zeros, then that string should not be accepted. Now where should I send this transition? If you get 0 in state 0, 0, I have to send it to state Q, because Q is the only non-final state that we are having in this DFA. So on getting input 0 in state 0, 0, if I send it to any other states other than Q, it will be accepted because all these states are accepting states or final states. So one thing for sure we can say is that if you get input 0 in state 0, 0, it has to go to this Q, which is a non-final state. So let me draw the transition. So if it gets input 0, it will go to this state Q. Now this is something that we are sure of. Alright, now before we proceed, let us see among these options which are the options in which this transition is there. Now if you look at this option A, we see that in state 0, 0, if you get input 0, it is sending it to state 0, 1. But no, we are supposed to send it to state Q. So option A is wrong. So it is out of our consideration. Now in option B, if you look at this, in state 0, 0, if you get input 0, it is also sending it to 0, 1, which is not acceptable. We have to send it to state Q. So B is also wrong and it is out of our consideration. Now we have options C and D. In option C, we see that in state 0, 0, when it gets input 0, it is sending it to state Q, which is what we just drew over here. So option C could be correct, and in option D also the same thing is being done. In state 0, 0, when it gets input 0, it is going to state Q. So we have to now consider only states C and D. So this is how you can save your time during the solution of this problem. Instead of trying to design the entire missing arcs, you can just look at these options and proceed. So you don't have to consider option A and B anymore. And now our only question is between option C and option D. Alright, now let us proceed with option C and see what happens. So in state 0, 1, that is this one. So in state 0, 1, we see that it has a transition for input 0, but for input 1, it does not have a transition. So it says that on input 1, it goes to state 0, 1 itself. Alright. So let's assume that it is correct, and let us just go to the next transition. So here in state 1, 0, that means in this state, if it gets input 0, it is sending it to the same state 1, 0. That means in this state 1, 0, if it gets input 0, it is going to itself. Now let us see what is the problem with this. Let's say that we came like this from state E, we got input 1, then we got input 0, and if we get another input 0, we stay in state 0, 1. So let me write it over here. We got 1, 0, 1, 0, and then if you get input 0 here, we stay in state 1, 0 itself. Now let's say that we get one more 0. So if you get one more 0, what happens? It still stays in state 1, 0 because it is a self loop over here. And 1, 0 is a accepting state. So this string is going to be accepted. But we see that here we are having 3 consecutive zeros. So if I consider this substring of 3 symbols, it is having more than 2 zeros. So this is not acceptable. So that means this transition over here is not acceptable and it is wrong. So hence we can say that option number C is also wrong. Alright, so we found out that C is wrong, and now that leaves us with only one option, which is option number D. So if you look at the question, we have options A, B, C and D. So the answer has to be one among these. So we found that A, B, C are wrong. So that leaves us with only option D, and option D is the correct option. So if you want, you can draw the missing arcs using this transition table, but I will not be doing it right here. So this is how we can solve this problem using minimum amount of time without solving the entire thing. So now if we apply this option D and draw the missing arcs, we will see that the language that we had, which says that every substring of 3 symbols will have at most 2 zeros. So this will be satisfied, and then our DFA will be complete. So the correct option is option D for this question. So I hope this was clear to you. Thank you for watching and see you in the next one.